Hello, I'm Julie and I'm going to be your instructor this session. Let's start with our learning goal. Our goal is to solve logarithmic equations, specifically ones that result in secondary linear equations. If you look over here, this is such an equation. We want to solve this equation as our major learning goal today. So 2 times the logarithm, natural logarithm, of x plus 4 minus 25 equals minus 7. Notice the logarithm is in blue. This is because it's a relatively new object. The rest of the equation should be very similar. If we take a look at a similar equation with the same structure, 2 times some expression minus 25 equals minus 7. It has the same structure as our original equation, the only difference being the original equation has the logarithm. This equation you should recognize. That's a linear equation. So let's quickly review how to solve this linear equation. The first step, as you might recall, is to use the addition principle or property of equations and add 25 to both sides. Remember, whatever we do to one side of an equation, we want to do to both sides. So we add 25 to y, negative 7 plus 25, 18. Our next step will be to use the multiplication or division property of equality. So we'll divide both sides by 2, the coefficient of y. And we'll have y equals 9. Alright, this was a fairly simple procedure that everyone should be familiar with. So solving the linear equation, we added the same thing to both sides, divided both sides by the coefficient of the variable term, and isolated the variable. Let's do that exact same procedure to this logarithmic equation in order to isolate the logarithmic term. We want to isolate this term in exactly the same way as we isolated y. So what are we going to do first? Add 25 to both sides. So we'll have 2, and I'll keep my logarithm blue to highlight it. Equals, add 25 to both sides, negative 7 plus 25, 18. What did we do next over here? So after we added 25, we divided both sides by the coefficient of the variable term. We divided both sides by 2. Let's do the exact same thing over here. Divide both sides by 2. And that isolates, completely isolates, our logarithmic expression. Notice a similarity between what we've done here and what we've done here. Here we have y equals 9, our variable isolated equals 9. Here we have the variable expression, the logarithmic expression, isolated equal to 9. Alright, now we're going to have to do a little bit of skill intervention in order to remove this logarithmic expression from both sides. So let's move over to our sideboard. Logarithmic functions and exponential functions of the same base, in this case base A, are inverses of each other and can be used to eliminate one another from an equation. Just as we use, say, division to eliminate a multiplication or subtraction to eliminate an addition. If we take the base A of a logarithmic expression with base A, these will eliminate and we get the argument of the original log. So 2 raised to the log base 2 of x, these eliminate, we get x. 3 raised to the log base 3 of, in this case, the expression x plus 5. the exponential expression, or exponential function, eliminates the log function, and we get the argument of the log. Down here I've written e to the log base e of x plus 4 equals x plus 4. But remember, we usually don't write log base e. What do we write? ln. The natural logarithm function is log base e. So this becomes e to the natural exponential function to the natural logarithmic function of x plus 4. These eliminate, and we obtain the argument x plus 4. Now let's move back over to our main board. Here we are back at our main board. Remember where we left off. We started with the goal, solving this logarithmic equation. We added 25 to both sides to eliminate the minus 25. We divided both sides by 2 to eliminate the times 2. Now we wish to eliminate this logarithmic expression. That's what we were just talking about. So let's go over here. Using the natural exponential function, e to the x, to eliminate the natural logarithm function. Let's import what we had. We had ln of x plus 4 equals 9. So what are we supposed to do to eliminate the natural logarithm? Apply the natural exponential function to both sides, because the natural exponential function has the same base and is the inverse function and will eliminate the logarithm from the equation. E to the ln of an argument, these eliminate, and we get the x plus 4. Notice we still have the e on the other side because we had to apply e to both sides. Remember, whatever we do to one side, we have to do to both sides. Now this is just a number. This is a very simple linear equation. X plus 4 equals a number. Just subtract 4 from both sides using the subtraction property, and we get our final answer to our original logarithmic equation is e to the 9 minus 4. This is the exact answer. If we want a decimal approximation, we can put that in a calculator. But this is our exact answer to our original logarithmic equation. We have one more order of business before we say goodbye to this problem. Our original logarithmic equation was 2 times ln of quantity x plus 4 minus 25 equals minus 7. It involved this logarithmic expression. If you remember from earlier studies, the logarithmic expression has a restricted domain. We can only take the logarithm, natural log, or any other base of positive numbers. We don't know before we start what x is, so we don't know whether we're trying to take it of a positive number or not. But we've solved this equation, and we discovered that x is e to the 9 minus 4. So the question remains, is this appropriate? Can we take the logarithm if we use this for x? So it's not about whether this is a positive number or not. It's whether when we put it into our argument, in this case x plus 4. So the argument of our logarithmic expression, log of quantity x plus 4, is x plus 4. So we want to make sure x plus 4 is greater than 0. We've discovered that x is e to the 9th minus 4. So we plug that in for x. E to the 9th minus 4, that's our x, plus 4 from our original argument of the log. The minus 4 and the plus 4 eliminate. We get e to the 9th. You can plug that into your calculator if you so desire, but that is a very large number, very large positive number. So taking the logarithm of x plus 4 when x is e to the 9th minus 4 has us in fact taking the log of e to the 9th, which is positive, so we're fine. Alright, now it's time for you to practice what we've just gone through, what you've just learned. This is a guided practice problem, so you should have a paper that helps you go through this solution process. Solve 5 times the natural logarithm of x minus 2 plus 4 equals 14 for x. Use algebraic solutions as we've just gone over. Find the exact solution. When you're done, look for the video going over the guided practice problem for objective 1 to assess how you've done.